So if you want to have a good life, you need to have good, comfortable buildings. If you want to have a productive economy, you need to have productive buildings where people can work and be productive. So these are some of the challenges facing building designers, people that are financing these buildings, and people that own and operate these buildings. And this is some of the challenges that we'll discuss on this panel. Also, because buildings are so long-lived, because when you build a building, you hope that it will last for 50, 100 years or more, it's critically important that we get our buildings right now, because we can't afford to be building bad buildings when we know that they'll stand so long and that it will make it impossible to avoid catastrophic climate change if we add a number of bad buildings to our existing building stock. And of course, it's critically important that we improve the characteristics of the existing building stock, because each year our building stock only grows by about 1% and less than that in a slow economy like this. So it's critically important that we get our existing buildings to perform as well as they can, to be healthy, productive, and energy efficient and green buildings. So this panel will discuss that. We'll have each present for, I think, 5 minutes, and then we will have a round of questions for all of our panelists, and then we'll take questions from the audience. And we're just going to go in alphabetical order for presentations. Again, we have a great panel. I think you're going to be very pleased with these presentations. First, we'll hear from Dr. Kurt Becker. He's Associate Provost for Research and Technology Initiatives, the Professor of Applied Physics at the Polytechnic Institute of NYU. And he received his MS and PhD from the Universität in Saarbrücken, Germany, in 1978 and 1981, respectively. Prior to joining NYU Poly in 2007, he held faculty positions at Lehigh University and the City College of New York, CUNY, the Stevens Institute of Technology. And at Stevens, he was the head of the Department of Physics and Engineering Physics and the Associate Director of the Center for Environmental Systems. And I'm going to hand it off to him, and I will introduce each speaker right before they speak.
Is it on? What's the mic on?
Do you want to stand here, or I can advance your slideshow, either one?
I can stand here.
Okay.
Good morning. First of all, I would like to thank my co-worker and collaborator, Barbara Kate-Skarnick, who was instrumental in putting these slides together. And you will see a lot of words on the following 3 slides. And the reason is I took her ideas, and rather than that she presented to me in 8 slides, rather than cutting, I just condensed them. So there's no chance that in the few minutes I can really go over all these slides. And but I just want to get some key ideas across. I'm a physicist by training, so innovation and technology is in my blood. What I had to learn in the past few years is how to make innovation and technology relevant to the end user. And let me start off with my view of what innovation is. Either in the built environment or any place, to me, it's a new way to achieve a familiar goal. And that new way can be more efficient, more economical, faster, cheaper, you name it. And with that definition, innovations really come in 2 broad categories. One are disruptive innovations. They mean a radical change. They have a big impact. There's often a high resistance to their implementation because of cost, or they require a radical change in human behavior. Let me give you a simple example. The invention of the elevator allowed us to innovate the way how we get from one floor to another. Use the elevator rather than the staircase. That was a disruptive innovation. Incremental innovations usually mean only marginal change. They have a low impact, and there's often very low resistance to their implementation because it doesn't force you to change your behavior a lot. And an incremental innovation in that space would be to go from a manned elevator, which many of the co-op buildings in New York still have, where you enter the elevator and there's a person taking you up and down, to a fully automated elevator. I'm just going to go through the highlights here. First thing is, if you want to bring innovations and new technologies to the market, you got to set the goals. One of the first goals that everybody believes in is like motherhood and apple pie, reducing energy consumption and the carbon footprint. From a technology point of view, the hungry entrepreneur, if you can unleash their potential, that's a major step in really increasing the innovative power. And in order to do that, you need to bring the early stage entrepreneur together with the early stage investor, angel or VC funds. And when you bring technology to the market, you have to have a measure to really see what the impact is. You can have the coolest technology, but if the impact is marginal, nobody will actually embrace it. One of the key elements to making innovation and new technologies relevant is to bring them to the table, into the planning stage very early on, rather than do your planning and then scratch, what kind of technologies do we have out there that could help us. Bring the technologists to the table and involve them in the planning process. So my last slide is just a summary where we stand today and the next step, how to make innovation and new technologies more relevant. If you look at new technologies in the space of the built environment, they're mushrooming, they're doubling, quadrupling almost every month. Often they're very early stage. Areas where you find these new technologies are new technologies for real-time performance monitoring of buildings, be it energy, be it water. Technologies relating to fully integrated building systems, fully integrated communication systems, new ways to produce clean energies, to store clean energies, and a wide range of new materials. To me, a key component in making new technologies relevant is testing them in business incubators and business accelerators. Why? If you've ever been to an incubator, it's a hotbed of the innovative spirit. You have all these entrepreneurs who have this do-or-die attitude because they need to make payroll the end of the month. So there's no 9 to 5. There's 16 hours a day, at least 16 hours, at least 6 days a week. And these guys are incredibly inventive. They need to know everything from accounting to how to fix a fax machine. The other component that's important is the business incubator and business accelerator, because what these people are doing is seek financing for their new technologies. It's an early test of the marketplace relevance of the emerging technology. You can have the coolest technology, but if there's no market for it, it will be shelved. The next steps that I've outlined here, there are two that are really important to me. One is to create meaningful partnerships between the various stakeholders, such as our research universities, technology companies, and the government. The recently launched Urban Technology Innovation Center by the City of New York can be one of these examples if we learn how to do it right. And lastly, nothing convinces early-stage investors more than when you can show them that your idea, your technology works. So small-scale demonstration projects that demonstrate feasibility or proof of concept are incredibly important to go to the next step. And with this, I end my introduction.
Thank you. Thank you, Kurt. Our next panelist is Bob Fox. He is one of New York City's most highly respected architects and leaders in the green building movement. He serves on numerous advisory committees and has been honored with many awards. A founding partner of Fox and Fowl Architects, Bob's work there includes the influential 4 Times Square Condé Nast headquarters. And in 2003, Bob joined Rick Cook to form Cook plus Fox Architects, a firm devoted to creating beautiful, environmentally responsible, high-performance buildings, including the Bank of America Tower at 1 Bryant Park. In 2006, Bob and Rick joined Bill Browning and Chris Garvin to form Terrapin Bright Green, a green strategic consulting firm. Bob. Oh, sorry, yeah, let me cue up here.
Thank you, Cliff, and I'd also like to thank the NYU Shack Real Estate Institute for inviting me to be part of this incredible event. It's really, just looking at all the speakers, it's fantastic. What you're looking at is the tallest building in these images is the Bank of America Tower at 1 Bryant Park. It is 2.2 million square feet and is LEED Platinum. And I want to say from the outset, we did not start this project by saying, how do we get LEED Platinum? We started this project with our team, which involved the Durst family and the Bank of America. We said, what is the best building we could do? What's the best we could do? And I suspect some of you are, or all of you are involved in real estate, and why would you start a project that you say, well, why don't we do second best? Or why don't we just do okay? Why don't we start out with our team of engineers and the people who are running the building and all kinds of the people who get together to build a building, why not start out with saying, what's the best we can do? So we looked at water. What is the best we can do in water? Because these big buildings consume vast amounts of water. So we said, why don't we take the free water and use that? So the free water comes from the sky. There's 4 feet of water every year that hit New York City. So we're going to capture all of that water, or we are currently capturing all of that water. We treat it slightly, and we use it to flush the toilets and for the cooling tower makeup in the building. This saves us about 10 million gallons of potable water a year. About half the building's consumption is free. City DEP liked that idea when we proposed it to them, and they said, wow, we'll give you a 25% reduction in the cost of water. The cost of water has gone up 5 times since we started this project in 2003. And anybody else who does this, saves that amount of water, we'll give them the same reduction in the cost of water. Not a bad strategy. We then looked at energy and started by looking upstream. Where does the energy come from in New York City? Well, it comes from a pretty fragile system, but it's a pretty inefficient system that 2/3 of the energy that is used to make our power goes up smokestacks somewhere else, and 7% is lost in the transmission getting from the power plant to the outlets. So we have a 5 megawatt, meaning pretty darn big, cogen plant in the building. It makes 2/3 of the building's annual energy on site right in the middle of Manhattan. And during the day, it provides most of what the building needs. Con Ed supplies the rest. But at night, it makes too much. So this plant only works well if it operates at full speed all the time. So at night, it makes too much. So we use that energy to make ice. And we have an ice storage farm about almost as big as this room. In the lowest cellar, these tanks are pretty heavy. And at night, we freeze them solid. And then during the day, in a day like today, these big office buildings are air conditioning all the time, even in the middle of the winter, because there's heat that comes from us and our equipment and lights. So during the day, the engineers very carefully decide when to melt it, because as the consumption of these buildings goes up, the people who pay the bills pay a demand charge. So the higher your demand in any given month, the more you pay. And if you can cut that demand down, it's a significant amount of money. So in the middle of the day, this building is being cooled by melting ice. So, and the building will use about half the energy of a typical office building. So, okay. We then started to look a little further, because if you look at the cost of this stuff, it's a round-off to companies. More than 80% of a typical corporation's expense is for their people. More than 80%. So the answer, certainly to the Bank of America, is, well, give us a healthier and more productive work environment. And yet we like the energy stuff. But if we could get a 10% increase in productivity across the board of the Bank of America, that would equate to about $100 million a year. $100 million a year. That's nice, round, good number. So how do you do that? We filter the air at a level that's better than most hospitals. It's a 95% particulate filter. We deliver it under the floor. We give everybody that works at the Bank of America a view outside. There's a science called biophilia, what it means to us to connect to nature in health and well-being. See the sun out, see whether it's raining or snowing, see trees, and even see the horizon in New York City. And that has been a terrific experience. The building, we did get LEED Platinum. We used LEED as a scorecard, not how do we do it, but how well did we do. And the building's been occupied for a couple of years, and the evidence that we get from the people that are in it, that they are indeed on their way to a 10% productivity increase. You know, in my introduction, it never said techno anything, so I pushed an arrow?
Yeah, that's great.
Okay. But I want to talk about something that may or may not fit into this discussion and hopefully will inspire a little bit. Cliff mentioned that I'm a partner in a company called Terrapin Bright Green. Terrapin just got a wonderful grant from NYSERDA, the New York State Energy Research Development Authority, to explain the science of biomimicry to the manufacturing companies in New York State. If we mimic nature, and until we all admit that we're part of nature, but if we're going to have a problem. But if we mimic nature, there's a lot to learn. And the example I'll use is Interface Carpet, who started making carpet squares. And I know all of you have seen instances where they replaced the carpet square because somebody spilled some coffee on it, and you got the new one, and you could see it from across the room. Interface went to a biologist named Janine Benyus and said, is there something we could learn from nature in this carpet stuff? And they said, yeah. Look at a forest floor. It's always different. It's changing all the time, but you can't tell. So they came out with a line of carpet called Entropy, mimicking the forest floor, and no two tiles are alike, like no two leaves in the forest, like no part of the forest is alike. And you can put in different dye lots. You can change this carpet, that carpet. It doesn't care which way it goes. It can turn it. There's no science to laying this down. And it's been their #1 selling product since then. Interface is the largest carpet company in the world. And then they looked even further and they said, we're putting this stuff down with glue. And when you put it down with glue, it gets all over the workers' boots and it's a mess to pick up if you have to change anything. And they again looked at nature and they looked at a gecko. And the gecko can stick to anything. And they made something called a tactile, which is a little square about that big. And instead of using glue, the tactile glue gets stuck to the underside of the carpet, not the floor, the underside of the carpet, and creates this very large mat that doesn't move. So no more glue, little tactile, incredible opportunity. My last image is our home. We have an office, and the existing building stock has been alluded to a lot. 85% of the buildings that will be here in 2030. Mayor Bloomberg's plan is designed to reduce the carbon footprint 30% by 2030. 85% of those buildings are already here. So the new buildings don't matter. We're never going to get to 30 by 30 if we don't look at the existing buildings. This is the roof of our office space. We're in an old department store built 100 years ago in the Ladies' Mile, and we said, when we started our project 5 years ago, we said, well, I think this is the chance, the opportunity here. We got to walk the walk because we can't tell our clients that they've got to do LEED Platinum buildings if we don't do it at home. So we did. And people come to our office and they say, hey, this is very nice, very nice. But the #1 thing that they look at is that roof. That is the roof on our building. It gave us no LEED points because it's not in our space. It has great benefit to the tenant below us, and it has benefit to the city. It absorbs water and combines sewer, stormwater runoff, and everything. It does great things for everybody else. It didn't do a bit for our LEED points, but it is the #1 thing we would do immediately if we did this project over. Thank you very much.
Thank you very much, Bob. Let's go ahead. Next, we're going to be hearing from Dr. Young Lee. He is a senior researcher at IBM, a research staff member at IBM's T.J. Watson Research Center. Dr. Lee received his BS, MS, and PhD degrees in chemical engineering from Columbia University. He has been working at IBM Research for 8 years and has also worked at BASF for 14 years. He's developed numerous optimization and simulation models. In the last 5 years, Dr. Lee published 5 book chapters and more than 20 technical papers in journals. He's filed 18 patent applications. Dr. Lee has won 2 IBM Research Division Awards and a BASF Technical Achievement Award for his mathematical modeling work. Dr. Lee. So hard to use these mice.
Good morning, and thank you for the introduction. For my introduction, I'm going to talk about the analytics, how we can make a building smarter through analytics. There are 3 elements in making building smarter. One is instrumentation. As we all know, many commercial buildings now have a building management system, many sensors and meters, and collecting thousands of data every few seconds and few minutes. And then even in the residential house now, many houses are getting smart meters, programmable thermostat, and so on. So through all this, people are more interconnected with the buildings through the system and tools and so on. But the real opportunity comes from this intelligence side. This is where with all this information we collect from various systems, how we can use this information to make a more informed decision so that we can use energy more efficient manner and reduce greenhouse gas emissions. So there's a huge opportunity here, and there is so much data available, but these data are often underutilized. We have seen many buildings collecting thousands of data, but people don't even know how to access this data. Okay, so there's a lot of opportunity, and for scientists and mathematicians, this is a great opportunity. There's so much information available. There are so much science and mathematical techniques you can apply to use this data to make a building smarter. So to give you some example of smarter building analytics. So smarter building analytics are physics-based analytics, or it could be statistical-based analytics or mathematics-based analytics. And some of the things we can do with this, first, we can do good assessment of how different types of energies are used in a building for different ways. Also, this includes the greenhouse gas emission. By understanding how we consume our energy, we can have a better idea how we can use the energy more efficiently. The second one is the benchmarking. With this analytics, we should be able to benchmark how much energy our building uses versus other buildings in the peer groups. And by comparing and identifying a building with the inefficient energy consumption, we can find opportunity for savings. Other things we can do is detection and diagnosis. Through this analytics, we can identify fault and anomaly that could lead to the failure of HVAC systems and also wasted energy. And also we can identify root causes for these problems. Other things we can do with analytics is tracking. Not only can we track the energy consumption over time, also we can track the, when we implement some kind of retrofitting actions, we can track the benefits from that retrofitting actions through this analytics. We could also forecast the future energy consumption and also greenhouse gas emissions. So, some unusually cold March or the February, so what they're expecting, we can estimate how much energy we will be consuming and so on. And other things is simulation. Using this analytics, we can simulate the various changes you can make to the buildings on the energy consumption and greenhouse gas emissions. So this change could be structural changes such as retrofitting. Before you implement the retrofitting, using these tools, you can estimate how much of energy you can save and how much of greenhouse gas emission you can reduce. This change could be operational changes. Certain building, if you change the occupied hours, If you change the set point of a thermostat, how much energy you can save. Other thing is simulating a behavioral change. If people change their behavior, and for example, turn all the PC off at night and so on, we can sort of estimate how much energy you can save through this tool set. Other thing is external change, such as weather. And ultimately, using this tool set, we can also optimize energy consumption, energy efficiency, and greenhouse gas emission. To give you some example, this optimization could be the retrofitting planning. You have a limited budget and you have many buildings where you can apply retrofitting. What's the best retrofitting you should apply to which buildings? Deciding that. Also optimizing a scheduling of energy consuming activities. Since electricity price change drastically during the day, by scheduling energy consuming activities at different time of the day, you can not only save money and the energy, but also there's a great environmental impact. Using this tool, you can identify what's the best way of generating on-site energy and what's the best way of storing energy through the ice and hot water and so on. So this analytics should consider not only the demand and operation supply, but this analytic should consider all three of them simultaneously. That's very important. So to give us an example, even if the certain building could have a very efficient HVAC system, which does a good job maintaining a set point and so on, but even the HVAC machines are running optimally, if people open the window when air conditioner is on or heater is on, a lot of energy could be wasted too. And also when people tamper with the thermostat, they could also waste a lot of energy. Another example, even if people installed very energy efficient appliances at home, if those appliances are running at the late afternoon where electricity demand is highest, which will have a great impact in terms of cost and also the environmental the effect. Also, we should also consider the supply when you are developing analytics as well as the demand and operation, such as the on-site generation and the various types of renewable energy which are available different time of the day and so on. So in this the global optimization, simulation, and analytics, we should consider all three: demand, operation, supply, and also the external factors such as weather. And we should also consider in our calculation, in equation, not only the minimizing energy use and minimizing cost, but also minimizing greenhouse gas emissions. So by considering all these factors together, we could really make a building smarter. So this last slide, I'll give you some example of smarter building, the analytics. So here in the middle, we have this data repository which collect here building and energy-related data from various sources. So this could be from the building management system, it could be meters and sensors, energy bills, building characteristic, plug load, weather information, and also EPA data. All these data are nicely organized into the data repository where the various analytics can be developed. So using this data, in the middle you have a bunch of analytics which utilize this data and automatically calibrate the model. So this could be a statistical model, it could be a multiple regression model, time series model, and it could be a heat transfer model, and also it could be the greenhouse gas emission calculator. So then using this underlying the fundamental models, we can do various simulation and optimization and anomaly detection and so on. So we do the forecasting, we can do the simulation, whatever. And all these analytics are available to users through this nicely looking dashboard, analytic dashboard. Using this dashboard, the user can not only see the information on the energy, but also trigger various analytics to make an informed decision to make buildings more efficient. So this is my the introduction for. Thank you.
Thank you, Dr. Lee. Our next presenter is Tom Paine. He is the Director of Sustainability for the New York City Department of Design and Construction. His 25-plus years architectural career includes being a partner in his own firm, project management in corporate architectural firms, and public service in major New York City agencies. Since 1997, when he worked for the DEP on a waterfront education center that incorporated LEED design long before it was commonly accepted, Mr. Paine has taken into account the environmental impact of every project he has worked on. As Sustainability Director, he oversees some 70 projects that are required to meet LEED certification, mostly through New York City's Local Law 86, as well as creating practicing professional education program through the publication of training manuals ranging from water use reduction to geothermal technology. The sustainability program, New York City Sustainability Program, started in the late 1990s with high-performance building projects and now concentrates on intense energy saving and greenhouse gas emission reduction to align with Mayor Bloomberg's Plan YC 2030 goal of a 30% reduction by 2017. Tom Paine.
Oh, yeah. Oops. Not go on, maybe it went somewhere else.
What's the name?
It would have been Shack Institute, NYU Shack Institute. Maybe it went on another panel.
Do you want to wing it?
Okay.
Sorry, some technical difficulties. We don't have a slideshow for him. He's going to wing it.
All right, we'll give it a try. So we've heard about process. We've heard about the latest avant-garde methods for sustainability, and we've heard about metrics. So now, in these very few minutes, I will talk to you about how we spend public money to be sustainable. The Department of Design and Construction is the city's capital improvement construction manager, with approximately $3 billion worth of construction going on at any given time. Approximately half of that is infrastructure, so that's sewers, water mains, public right-of-way improvements, and the latest would be green infrastructure. Even in the tornadoes that happened last spring, was the Department of Design and Construction that had to get these sidewalks rebuilt very quickly, and we did manage to do several pilots using permeable paving, which we are now in the process of testing to see how well that works under city conditions. The other half goes to building projects belonging to the municipal government and financed by the municipal government. So the map you can't see is all of our projects throughout the city to the end of south end of Staten Island to the northern Bronx. We have projects going on all over the city. Since you can't see it here, you can go to, you can just Google New York City map, and it's the Do-It map, and it's an interactive map, and you can get all kinds of information by zeroing in on any neighborhood. You can see where the water fountains are, where the firehouses are. It's a great map. I urge you all to use it if you're interested in building in New York City. So we partner with other city agencies by partnering design and technical consultants to meet their program and architectural needs. It's a large construction program with a great diversity of project type, ranging from museums to courthouses, to jails, to zoos, to botanical gardens. And we do this despite Professor Glazer's comment about regulation. We do have something called Local Law 86, which is really what was able to boost our efforts in doing sustainable building, because now any project basically spending $2 million or more has to meet certain sustainability goals. To date, we have 7 projects obtaining LEED certification. We have another 38 in process of doing so. In addition to the entire capital program with comments to the existing building stock, we partner with the Department of Citywide Administrative Services to participate in the mayor's plan. You heard about the 30% reduction by 2030, but the mayor's executive order is a 30% reduction in greenhouse gas emissions over 2005 levels, but by 2017. that's really around the corner in terms of planning and spending public money. It's a very ambitious program. The mayor has put $100 million annually behind it. We are currently working on 320 buildings. What we're doing is audits and commissioning, lighting upgrades. This is a lot with the recent legislation that you'll all be affected by in your own buildings, but we're jump-starting it. And just to give you an idea, the city's buildings alone are 5,000. It's a portfolio of 5,000 buildings. So there's just a couple of examples. Again, you can't see, but you can go online. The Brooklyn Children's Museum, it doubled the original space. It uses a geothermal system that taps into an on-site aquifer that's 340 feet below the ground. The constant temperature, it's an open loop system, and it works for both heating and cooling. It avoids the noisy use of cooling towers. There's also a photovoltaic array to provide on-site energy generation. All of the energy modeling for this building was done through a program through NYSERDA. The second example is the Queens Botanical Garden Administrative Building. It too uses a geothermal system, an open loop system. But everything about this building is sustainable because the client wanted it to be such that would fit into their philosophy of ecology. So there's a green roof that starts at ground level and swoops up a vast ramp over the auditorium. There's photovoltaic array, composting toilets. Everything in the building is sustainable, and it is one of New York City's greenest buildings. It received a LEED Platinum in 2008. And finally, if you go to our site, the Department of Design and Construction site, to the sustainability area, we have an education program, and so we produce many manuals, how-to manuals of how you can make your buildings greener. There's a sustainable urban site design manual, energy-efficient lighting, cool and green roof, geothermal manual, high-performance buildings, and in about 3 weeks, you will see the water conservation manual. Okay, thank you.
Thank you very much, Tom. Now, our last presenter is Chris Pike. Chris is the Vice President for Research at the U.S. Green Building Council. He directs a diverse research portfolio that includes next-generation rating systems, the assessment of building performance and occupant experience, and the study of market trends and dynamics. The research program develops and applied advanced information technologies to inform and accelerate market transformation, such as the Green Building Information Gateway, gbig.org, and I've used it, it's cool. He holds a PhD and MA in geography from the University of California, Santa Barbara, and a BS from College of William and Mary.
Great. All right, I got a couple of dubious distinctions. So I'm the last person before the questions, before the coffee. So it's my job to take us to that particular finish line as quickly and as enthusiastically as possible, I think. And along the way, I appreciate some of the questions that Constantine and his colleagues put together for us. So I'm going to try to hit you with 3 different points, and I'm going to start and end with this curve. So I think it's my position here to talk a little about the role of rating systems as a concept in high-performance green buildings. I'm going to talk about some of the barriers that we're currently experiencing, and then my little pitch on what I think amounts to pivotal technology, and I hope that this ties together some of the remarks you've heard today. For me, the curve you're looking at is what got me interested in green building. It is what I think we are trying to do, and sometimes we forget or sometimes we don't agree. Don't agree, I can understand. Forget, we're going to try to fix. So 18 years ago or so, when folks like Bob were instrumental in creating the green building movement, what I understood that we were trying to do is change the prevalence of practice. Basically, we were trying to change the frequency of performance and practice in the industry. And the hitch, though, is that although this curve appeals to the scientist in my head, which says there is a mean of practice, and then there is a tail that has high performers, and there's some scofflaws on the other side, there was never any data. There's still never any data. We don't know what this actual curve looks like, but that didn't stop us over the last decade and a half from trying to move it. And that's what we're trying to do. And when we understand what green building is, which I think echoes what Bob was saying earlier, is that a green building is not a goal if that goal is a plaque on the building. That's not the goal. The goal is to use green building to change that distribution. And I want to basically articulate that there are a number of pieces, and I think in line with what Cliff opened us up with. Our goal is market transformation, shifting that distribution. We understand that that includes labor, that includes the professionals who have a common vocabulary, a common understanding of that goal. It includes tools such as a scorecard or any other kind of tool that tells us what's good, what's bad, what's better, what's best. And we have a set of processes that allow us to verify high performance. And just like everything else in a real estate transaction, we trust, but we verify. And we believe it when we see documentation in that process. So a green building is the output of skilled professionals using tools, established benchmarks, through a set of processes that we hope to be as efficient as possible. And so what we've done over the last 15 years is make progress on each of these and begin to tangibly move that distribution forward. What I'm excited about moving forward, which I think resonates with things like what Dr. Lee was saying about his enthusiasm for some of the technology, some of the benchmarking, is the ability to generate those curves from real data and to create information technologies that in real time allow us to understand where we are and place a project, a prospective project in context and understand who the best performers are and who the worst performers are in the market. So where I want to go is I want to give you a quick snapshot from this new tool that we've developed, which I believe to be the first of a generation, at least for our organization, of analytical apps that will begin to use information technology to put data around that curve. And in line, one of the first problems we are overcoming, what green building does for the real estate industry is fundamentally that market transformation function is about efficiency of resource distribution, because up to now there is no Bloomberg for this part of the real estate industry. You cannot get your 2, 3, 4 panel display and tell me what's going on in any of these buildings. If I'm really lucky, I'm going to get an Energy Star score. Leading jurisdictions, New York, Washington, San Francisco. For the rest of it, I don't know, and the market cannot efficiently allocate resources if I don't know. So the first thing I need to do is be able to understand the relevant dimensions of those assets out there. Then I need to be able to take those assets in an analytical way and tell good from bad. And in fact, just like Bob was saying, which one of you wants to be the person that goes forward with a below average asset? What we're trying to do is be able to identify on a relevant performance measure. We can call that measure points, or maybe I'd prefer to call that measure something like some energy benchmark or some indoor environmental quality benchmark. And what I want to be able to do is take a specific asset. You can take, in this example, you can look at that little blue ball up there on the distribution and say that is a specific project in the DC metro area, and say how does it correspond to the distribution of all projects across an index that's composed of 10 or 12 different things you can do with regard to energy efficiency. All right, that's a project I think I would accept. It's not the best project in my region, but it's pretty dang good. And there's 2 things I can take from this. First off is I need to be able to establish that performance metric in absolute terms. What's best on the right, what's worst on the left, where is that distribution? Then I need to be able to understand this minute, what is the market delivering? What is the market delivered over the last 6 months, 12 months, 10 years? That's what this histogram is showing me. And then I need to be able to say, what am I going to accept? If my team proposed a project on the left side of that distribution, would I accept that solution? I don't think so. I'm going for the Lake Wobegon solution, where all the new entrants, all the refurbishments, all the renovations in my portfolio are above average. And then I'm going to take that information and shift that distribution. I'm going to add it in near real time to my distribution so that tomorrow that distribution shifts to the right, the bar goes up a little bit, and the next project has to rise up a little further. That's what information technology is doing. We're providing absolute benchmarks of performance. We are getting real-time intelligence, in this case, from what's coming through the certification stream at about 1 million square feet a day. And we're using that to provide a real-time benchmark about where's the market, where's the absolute measure, where's your existing or proposed project. That's what's different about now than 15 years ago. It's different between now and 15 months ago. and it's going to be really different 15 months from now. So with that, I encourage you guys to try this out. Check this out and give it a whirl. But more importantly, think about how this kind of information perpetuates this market transformation that green building is really all about. Thanks.
Thank you, Chris. Give each of our panelists a quick question, and then we'll take questions from the audience. If we could just go through each of you very quickly, what do you think are the most important market barriers to the advance of new technologies in the existing or new construction, or to the advance of other innovations? If you could go first, Dr. Becker.
Is this on? No. Well, I suppose I have a very simple answer to this question, is with almost every new technology, it's demonstrate the cost, the return on the investment. And I mean, this is really the silver bullet. If you can demonstrate that you can recover the cost of your capital investment within a time frame of, I don't know what's reasonable for this, for this industry, maybe 24 months, maybe 36 months, then you have a winner.
Thank you. Bob.
As I said before, I think the big issue, certainly in New York and probably other major cities, are the existing buildings. And I think the risk is that, my experience is that every single building is different. There's not one solution fits all. So I think the real answer is that for building owners to create a team of professionals who can really understand all the aspects of the building. In some of the older buildings, older, more beautiful buildings, if you put insulation in the wall that wasn't there in the beginning, you might rot the wall. It's been there for 100 years, it's doing fine, but if you mess with it and don't understand the moisture equation coming through that wall, you're going to make a pretty bad mistake, and those mistakes have been made. So must look at every building carefully and in depth.
Dr. Lee.
I think one of the most important things is that I think people's mindset. People should really understand why we want to save energy and also help reduce the greenhouse gas emission and so on. And just to give an example, I told one of my kids that my house is responsible for emitting about 50 tons of carbon dioxide, and she couldn't really relate what that is. So I told her that the amount of carbon dioxide we are responsible for is the same amount of carbon dioxide sequestered by 10 acres of wood. Then she started to understand what's the impact. So all of us should really understand, if you don't do anything, the global warming will reach about 6 degrees Celsius, about 8.5 degrees Fahrenheit by 2030, and that's going to create a huge impact on the environment. So when we really try to contribute in this reducing greenhouse gas emission and reducing energy, I think that's the really key things for making all this thing happen.
Well, Dr. Yi stole my comment, but maybe I'll say it in a somewhat different way. I think the most important thing is a cultural change. Basically, we're all here preaching to the choir. I mean, you kind of all know about green building. But we have regulations, in New York City, I think, is probably in the forefront of regulations. There will be water flow rates, restricted water flow rates to all plumbing fixtures as of July 2012. So my fear is we'll have people saying, I can't get enough water out of this thing to get the soap scum off. What is the government doing to me? But we need a tremendous education process that I don't think is quite happening yet. I live in a typical New York City block. The neighbors are great. But when I tell them what I do, they go, huh, what? You can make money at that? And they don't understand it. So it's it's education institutions like this that need to get the word out there.
I think I'm going to echo really quickly. I think the question was about technology and product, and I think that the issue, one of the lessons of this industry has been that clearly every product and every technology can be used inappropriately, and most have twice, and or more. And so the issue is that integrated design, making room for that integrative design or operations concept. And in my sense, one of the biggest barriers is letting that flow from the organization or the entity above it. What are the goals and objectives? What are the owner's project requirements? What are the policy goals that this building is trying to meet? And then have this vertical integration between those goals and this integrated delivery of the systems underneath it, and give these smart people the room to maneuver under those goals. That's what's gonna, and if we can innovate into that paradigm, there's an incredible amount of delivery that can happen. If we can't, we have some problems.
Thank you, Chris. We're running short on time. I'd love to get one or two quick questions, and if you could keep the question very short. Yes, please, ma'am.
Thank you. This is a question from Bob Fox. First, I'd like to congratulate you for being awarded this New York State grant on explaining prior failure to New York State manufacturers. I was fascinated with your slide about this carpeting. So I was wondering if you could tell us a bit more about what you would like to see as the outcome of the work that you do in this New York State.
Actually, the operative word here is biomimicry. It's as I said before, it's looking at nature and understanding how nature does things. And it's an opportunity for the manufacturing world to if the natural systems are incorporated, they have the opportunity to use less material and to use less energy in doing what they're doing, not only in the manufacturing process, but in the end result of what they are producing. An example is the way nature moves either through water, like fish, that can inform how shapes are used. It's how nature moves air and stuff. The fans, there's a company called Pax that makes fans based on the geometry of natural systems, like it's a Fibonacci series. It's a Nautilus shell, and can inform the way all the natural systems are fantastic. Our normal manufacturing is take, make, waste. That's how it works. We take stuff, we make something, and then it turns into waste. And nature has a total closed loop as to how it works, and it's mimicking that in a manufacturing process that will help us achieve all of the goals that we're trying to get to.
Thank you. Another short question. Yes, in the back there. So the question is, how is the sort of regulatory markets handling modular construction and the extent to which it's disruptive?
And how it relates to the framework of disruptive technology?
Well, I'll speak very briefly. I mean, certainly there are some real challenges there. Our whole infrastructure is not really accepting very much of modular construction in most cases, and so anytime you're doing anything innovative, that can create problems with financing, create problems with getting it through permitting. There may be need for education for the building departments. Modular is because it's constructed off-site. There's a question of, should the building department sort of accept it as at face value that whatever is said was done in construction was done and was done properly, or does it need to be tested and verified locally? modular tends to be regulated more at a national level because it's constructed and it can be installed anywhere. But the extent to which local departments are willing to accept that it's out of their hands, they'll accept the national regulation, varies, I think, greatly from place to place. Does anyone want to add more to that?
I think there's also a union issue, that the unions in New York have been reluctant to accept something that's built somewhere else and brought in here as a complete unit.
Right. Hey, it's a tremendous possibility for cost reduction, and it's easier to control quality in a manufacturing setting, in a factory setting. So there are huge benefits if we could overcome some of these barriers. All right, I want everyone to give our panel a round of applause.